I believe I left you with a problem you were going to do. And because where we left ourselves was determining if a pair of set relationships were true no matter what. And does anyone, I don't remember what I wrote on the board. Does anyone have that relationship?
The last one was A and B complement to equal A complement union B.
Oh, A and B were complements?
Yeah.
And what was I doing with them? Intersecting or union?
That was another set.
Okay, great. Okay, so I left you with this. I asked you to give it a try because we ran out of time on these examples. And then I said that's where we will start. So what we want to do is we want to determine if this has to be true. Okay, that is our point. That's why I put a question mark over the equal sign. I want to know, does this relationship hold up no matter what sets I pick? Because remember, I'm not asking you to make up sets because you can make up sets that'll satisfy almost any relationship. But what I want to know is no matter what A and B are, will they satisfy this? And so the way we do this, and we're going to see a bunch of Venn diagrams today. Okay, that's pretty much the bulk of chapter 2 deals with these drawings. So I got my Venn diagrams. And now instead of, just to get you up to speed, instead of putting elements in here, what I'm going to do is I'm going to label the 4 distinct regions. And I'm just going to describe what they are because the last example we're each going to do one of from this is we're going to do the same process with 3 sets instead of 2. So region 1 is the stuff that is only in A. Okay, that's how we would describe this part, the stuff that's only in A. Region 2 is the stuff that's in the intersection of A and B. Region 3 is the stuff that's only in B. And then region 4 is all the stuff that is not in either of those sets. Okay, so just trying to give you a little verbal description on what each of those regions represents. So if I did have sets, and we did a couple of examples of this when I gave you sets and said, put the stuff in the appropriate place, anything in the sets that was only in A, I put in here, etc. So now, we are going to demonstrate whether or not this relationship has to be true. So check your work with my work, hoping that you did this. It shouldn't have taken too long. So I don't know what this is off the top of my head. So I'm going to just go through the process. The complement of A. Well, A is composed of these 2 puzzle pieces, 1 and 2. So if I cover those up, the complement of A is 3 and 4. If I do something that bothers you, please let me know so that I can explain it better. I'm always nervous that I've not unmuted myself because I did record a video over the summer, never unmuted, and then people weren't good at reading lips. So that was, okay, so then B prime, so same thing. Here is B, it's 2 and 3. I'm going to cover that up. So the complement of B is 1 and 4, those pieces. And so now what we're doing with the complement of A and the complement of B, we're intersecting it. And just to make me happy, because we're reviewing, because we've got a test on Tuesday, what does the intersection mean? What they share, yeah. And so what region do these 2 things share? 4, yeah, thank you, perfect. Right here, right here. On the other side, I'm just going to rewrite just so that it's over here. Okay, so this is the same thing we just did, the complement of A. And just for fun's sake, I'm going to write down what B is. If you don't need to do this, that's totally fine. But B is composed of 2 and 3. If I put those 2 regions together, that forms the circle B. And so now on this side, I have A complement union B. So what region represents this? Well, again, just for my benefit, okay, I'm sure you know this, but I just want to review. What does the union mean? All of them, everything. Okay, so in this one, I have 2, I have 3, and then I have 4. And I had spoiled the surprise for you at the end of class last time. I told you what the conclusion you should have gotten is. So looking at this, A complement intersect B complement is represented by any elements that would be found in region 4. A complement union B is found by any elements in 2, 3, 4. Do these always have to be the same no matter what the sets are? No, because there's different regions, right? But you can see how I could make them the same, right? I could pick specific sets because I could pick specific sets that only have stuff in 4, and then it looked like the relationship held. That's why we don't do this and pick just specific sets. So is this always equal? And the answer is no, it's not always equal. Okay, question about that with 2 sets? Are you visualizing? I know this is new stuff, and we're just kind of skimming the surface of sets, having a little fun. Do you understand what I said about what these different regions mean? This is region 1's only A stuff, region 2 is both, region 3 is only B stuff, and region 4 is neither. Okay, you with me on that? Because understanding the regions, our last section is applying this, and the only thing you have to know is what the different regions mean. If you know that, you're going to be golden. Okay, one more example from each of us from this section, and then we'll get to the aforementioned section 2.5, the last section that we have. So this last one, this last example, we're going to be doing the same thing. So I want to know this. If I have A union B intersect C, okay, so we're going to do the same thing, but this time instead of 2 sets, I've got 3. We want to make 50% more fun. And I want to know, is this always going to be equal to this? A union B intersect A union C. Does that relationship have to always be true? I'll give you a moment to write that down before we investigate it together. This is 2.4. We're finishing up 2.4. This is not the new section. In fact, I've got a handout for you for the new section to make your life even easier. That's just what kind of great, amazing professor I am. Remember to review me kindly. Okay, so that's just a joke, everybody. Okay, so here we go. We're going to do this, but before I do, I'm going to draw my Venn diagram and I'm going to label my regions. So this time I've got 3 sets. If you remember, the way we started out section 2.4 is we introduced ourselves to Venn diagrams with 3 sets, and we had some sets, and I think one of ours was Disney movies was the example we did. And if you missed it, it's on the previous video. And we finally figured out how people can watch the videos. So now I'm going to label these, and we'll use this consistent label. Again, I'm going to use Roman numerals, but if you don't like Roman numerals, just use regular numbers. That's fine. So here we go. I'm going to start with A, and this is going to be region 1. If you had to use words to describe region 1, how would you describe any element in region 1? It's what? Only A, right? It's not, it doesn't touch any other set. Does that make sense? Okay, maybe you didn't see it right up front, but just make sure, write that down for yourself. That's important. Okay, so now this is going to be region 2. Now region 2 is a little more detail. Tell me something about region 2. It's A and B, but not just A and B because, well, yes, I'm sorry, I'm goofing this up. A and B, but I need to be just a little more specific. Okay, because this stuff here is in A and B, but it's also in C, right? Is this in C? No, so what I would say, the way I would describe region 2 is it's in A and B only, or it's in A and B, but not C. Does that make sense? Are you seeing that with regard to the circles? Again, I'm going through this not to bore you, but it's going to help us when we get to the next section, I promise. Region 3. Well, you probably catch on to that one pretty easy because it's similar to 1. Well, how would you describe region 3? It's only B. Yep. Region 4. How would I describe region 4? A and C only, or you could say A and C, but not B. Either way to say it, both of those are correct. Region 5, right here in the middle. Remember, a V in Roman numerals, if you're using Roman numerals, means 5. Okay? This is as much Roman numerals as you need to know in this class. And if you don't want to, you don't have to. How would I describe region 5? It's all three, yeah, or A and B and C. Yes, exactly right. Region 6, the V and then the I, that is going to be B and C only, or B and C and not A. Region 7, a 5 with 2 1s after it, is C only. And then there's one more, this is the last one. Region 8, a V with 3 1s. And how would you describe region 8? It's the universe. Everything here is in the universe, though. Be a little more specific. You're on it, though. It's anything not in A, B, and C, or anything except, or the stuff in the universe that's not in A, B, and C. Any way to say it, you just got to get across that it's not in any of our steps. Okay, great. Once you got that, here we go. I want to determine, is this relationship true no matter what sets that I pick? Because we have, more puzzle pieces here, I like to be a little more diligent. Maybe some of the things we could have seen fairly straightforward where there was just 2 sets. So what I'm going to do is I'm going to write down what puzzle pieces make up A, and then we'll keep going. So A, what regions, what puzzle pieces, when I put them together, form circle A? 1, 2, 4, and 5, or 5 and 4. Yes, perfect. Okay, so 1, 2, 4, and 5. Wonderful. Now B intersects C. Okay, that's just one operation, not too bad. So write down on your paper, just to see how this is chugging along for you, write down on your paper what region or regions compose B intersects C, the overlap of B and C. It sure would. Here's circle B, here's circle C. This eyeball or football is where they intersect. And so 5 and 6, yes, 100%. And then you just told me a minute ago, when I union things together, unioning means to take everything that I have. And so I'm just going to write down everything that's here. So I've got 1, 2, I've got 4, 5, and then I've got 6. So 1, 2, 4, 5, 6, any elements in those 5 regions form A union, and then in parentheses, B intersects C. Bless you. If there's any question, please. Questions are not bothers or burdens. They're not holding anything up. Questions are why we're here. So here's what I'm going to do now. A union B. So A union B is everything in A and everything in B. So when I come over here, here's circle A, here's circle B. That's a lot of puzzle pieces. Everything in A and everything in B is 1, 2, and 3, and then 4, 5, and 6. Okay, so everything in A, everything in B is 1, 2, 3, 4, 5, 6. So I'm going to write that down. 1, 2, 3, 4, 5, 6. Similarly, A union C, everything in A, everything in C. So here's my circle for A, here's my circle for C. And so forgetting the B circle, forgetting the universe, everything in A, everything in C is going to be 1 and 2 and 4 and 5 and 6 and 7. So again, A is this circle, my hand is covered, so that's 1, 2, 4, 5. C is this circle, and we've already got the 4 and the 5, and then the 6 and the 7. Okay, that's where I got those regions from. Those are the puzzle pieces. If this was one of those wooden kitty puzzles, and I just said, get the pieces that make A and C, you would grab these pieces right here. And the last thing I'm going to do now is I'm going to intersect these two things. And you told me a minute ago when we were reviewing, intersection just means what they have in common. So what regions do these two things have in common? Okay, I heard you say 2, I heard you say 4, I heard you say 5 and 6, and I'm going to go with you, but there's one more. And then a 1, yes. So they don't both share 3. 3 is only in the union of A and B. They both don't have 7. 7's only in the union of A and C. So it's 1, 2, 4, 5, and 6. Finally, we can answer the question, and you can do the very last problem from this section. The question is, no matter what sets I give you, no matter what A, B, and C are, what letters or numbers or smiley faces, do they always have to be equal? Are they always represented by the same regions on the Venn diagram? 1, 2, 4, 5, 6. Yes, no matter what, they are represented by the same regions. So this is a yes. Yes, these two things always will be equal, no matter what, no matter when. So here's your last problem for this section. And then like I said, we've got one more. So what I'm going to do, if anyone who came in a little late, I'm recording. So this will be up on Canvas about 15 minutes after class is done. I just got to download it. I'm not trying to leave you behind or anything. So we're going to use the same diagram, the same Roman numerals, or if you're using regular numbers, that's totally fine too. This is the relationship I want you to determine. Is this always true no matter what A, B, and C are? So it is A complement intersect B union C. Is this always equal to no matter what A union B intersect C complement? right, let's see how you did. Let's answer any questions that we have about this, and we'll go from there. So what I'm going to do here on the left is first, I'm going to write down the regions, okay? Because all 8 regions, the possible places that I could put elements of sets are labeled over there. And what I want to know is what regions describe the complement of A. So remember, the complement is everything outside of A. So with my hand, I'm going to cover up what A is. And so what regions are left over when I cover up what A is? 3, 6, 7, 8. Okay, so any elements that are in 3, 6, 7, 8. Remember, if the Roman numerals are goofing you up, then just use regular Hindu Arabic numerals that we're all used to because we've been using them since before kindergarten. That is totally fine. I'm trying to agree with what you're going to see in your homework, but also it's to help reinforce that we're not talking about elements in a set, that we are labeling the regions. Okay, so there we go. Now what I'm going to do is I'm going to figure out what B union C is. B union C is everything in B and everything in C. So here's everything in B where my hand is. Here's everything in C where my hand is. These 2 circles. So what are the regions that compose everything in B and everything in C? One more. 4 is also in C. Yes. So if you need to, if it helps, cover up A, because A does not matter at all to B union C. So it's 2, 3, 4, 5, 6, 7. So the last thing I'm doing now is I'm intersecting those 2 things. Intersecting means I'm going to take the regions that they have in common. And so what regions do they have in common? They've got 3 in common. They've got 6 in common and 7 in common. Oops. Yes.
So for the A complement, would that not include the 8 because it's technically outside?
Oh, you are good. I think we've got it though. But you're totally right. It will include. So the question, in case you didn't hear it in the classroom or on the camera, was A complement. Does that include region 8, which is the frame of the puzzle? So again, I cover up. Yes, 3, 6, 7, 8 are all part of the complement, and 3, 6, 7, 8. Right there, we got it. Okay, but no, it's great. Awesome question. It's great to have clarity. Over here, I'm just going to write down the regions that compose A. Here's A that I cover up with my hand. Now, instead of the complement, I want to know what's under my hand. So that's 1, 2, 4, 5. So B intersects C complement. So B intersects C. I'll just color it in blue so that B intersects C. Where B and C overlap is right here. So what's the complement? What's everything else that I did not shade blue? Perfect. Yes. So 1, 2, 3, 4, 7, and 8. This time we are unioning those 2 things together. Union means take it all. We're greedy. Here we go. I need 1, I need 2, I need 3, I need 4, I need 5, and I need 7, and I need 8 again. There it is. And clearly, my conclusion is, does that have to always be true? Are they always represented by the same regions? No, that one's got a lot more regions. But again, if we were making up sets, we could make up sets because they do share 3, 6, and 7. Or no, I'm sorry, just 3 and 7. So we could make up sets that only deal with those 2, and it would look like the relationship held. So the answer to this one is no. I'm going to put an exclamation point, and there you go. Before we leave this section, any questions, comments, concerns?
you said 5 is like, is it 5 in the middle, the middle of the shaded part? That's everything but the shading.
So B intersect C complement. Is that what you're asking about?
I'm talking about the last one.
This one?
Yeah, it's 1, 2, 3, 4, 5, but the 5 is the very middle.
Right. The reason 5 is in it is because we're unioning. And 5 was part of A. Right? 5 was not, you're right. You're completely right. 5 is not part of this right here. Because I colored blue what B intersect C was, and then the complement of that is everything else. So you're right. 5 is not part of this, but 5 was part of A. Because here's A, and that's these 4 regions right here glued together. And that's why when I unioned it, because union is take everything, that 5 comes down because it's part of the union. Okay, beautiful. See how easy questions are? It worked pretty good. I'm going to pause the recording.